In this video, I want to talk about number conversions. The College Board wants you to understand a couple of number conversions. And the first and the simplest is binary, converting binary numbers to decimal numbers. And binary is the simplest kind of number system that uses only two digits, 0 and 1. For example, this is a binary number. This represents some decimal number. And let's figure out how to convert this to a decimal number. So here's the same number. And what do all these ones and zeros mean? Well, they all represent a power of 2. This first column on the right is 2 to the 0 power. Then we go 2 to the first power, and then to the second, third, fourth, fifth, sixth, seventh, and eighth. And the way it works, it's going to go 1 times 2 to the 0 is going to give us this, and 1 times 2 to the 1. This is 0 times 2 squared, 0 times 2 to the third, and etc. And so how do we calculate? Well, these are all your powers of 2 to the first power, to the second, third, fourth, fifth, sixth, seventh, and eighth. And to calculate this number, you multiply 1 times 1. So I multiply down. 1 times 256, that's 256. 0 times 128 is 0. Of course, you get the ones, and 1 times a number or 0 times a number. And then finally, you add these numbers, 256 plus 32 plus 16 plus 2 plus 1. So this number 100110011 is equal to 256 plus 32 plus 16 plus 2 plus 1. And so this represents the number 307. Now we're going to look at a program in a few minutes about how to calculate something like this. But before we do that, I want to show you how to convert int to binary. So if I take 156, how do I convert that to binary? Well, you're just going to keep dividing by 2, and we're going to look at the remainder. So when I divide, 2 goes into 156, it goes in evenly, so there's 0 remainder, and it goes in 78 times. 2 goes into 78, well, it goes in evenly, and the remainder is 39. 2 goes into 39. Well, this time there's a remainder of 1. Notice these are all zeros and ones. It goes in 19 times. 2 goes into 19. There's going to be a remainder of 1. The answer is 9. 2 goes into 9. That is also going to have a remainder of 1. And I keep going until I can't go down anymore. This would be the last one. There's a remainder of 1. Now this is your binary number, and actually you read it backwards. So 100111100 represents 156. Now you're going to have to write a program to do this, and fortunately for us, we have something that returns the remainder for us. So if we did 156 modulus 2, it would return a remainder of 0. And then 78 modulus 2 would return a remainder of 0. 39 modulus 2 would return a remainder of 1. All right, we're going to move on to hexadecimal. Hexadecimal is a more efficient way to store numbers. You saw on the last slide that binary numbers can be quite long, but hexadecimal are more efficient. Instead of using base 2, we're going to use base 16. But in order to do that, we need extra digits. We have 0 through 9, that's 10 digits, but then we need A, B, C, D, E, and F. A represents 10, 11, 12, 13, 14, and 15. So let's look how to convert C921 into a decimal. Well, just like before when we were doing binary, these were all powers of 2, but now these are all powers of 16. So what you're going to do is you're going to multiply 1 times 16 to the 0 power. You're going to multiply 2 times 16 to the first power. 9 times 16 to the second power. And c, which is 12 times c to the third power. And then you need to add up all those numbers. So what is 16 to the third power? 16 squared, and then 16, all this here. And this is what I just talked about, 12 times 4,096, 9 times 256, 2 times 16, and 1 times 1. And we're going to add all those numbers together to get our final number, which is 51,489. If we were trying to represent this number in binary, it would be a number that goes all the way across the screen. So just taking 4 digits to represent this number is much more efficient than using binary. Now you're going to have to convert a hexadecimal number like AC into a decimal number, and I want to give you some help. Here's a great way to do it. If you make a string that goes from 0 up to F, it's these numbers place in the string, so its index in the string is its actual value. So 0 is at the 0th position, or index 0, 1's at index 1, 9's at index 9, A's at index 10, B's at index 11, etc. So how would you convert something like AC? Well, I know it's going to be A, whatever that value is, times 16 to the first power, plus C, whatever that value is, times 16 to the 0 power. So I take this first number out, I'm going to use a substring, and I go and find it. And I figure out its index, and I see, well, A is index 10. So I'm going to go 10 times 16 to the first power. Well, that's just 16. And I'm going to add to it whatever C is, and I take a substring, and I find C, and then I go and find C in my string, and know that it's at position 12. So I'm going to go 12 times 16 to the 0 power. 16 to the 0 power is just 1. And if I add these together, I get 172. So that should help you when you're doing your problem. Last thing I'm going to do is show you, this is in your notes. I want to show you how to convert a binary number into an int. And in this case, I take in a string, and this will help you on your next problem. I take in a string, so like this number 0, 1, 1, 1, it comes in as a string, right? And what I do is I take a substring of that, and I check each substring, and all I'm concerned about, I take this substring, and this substring, and this substring, and this substring. All I'm concerned about is if that substring is equal to 1, I know that I'm going to add that value. Because if it's not a 1, it's a 0, and then I've got 0 times like the number 8. 0 times 8 is 0. So I'm only concerned with the 1s, and I want to continue to add to that. So my substring equals 1. I figure out what my power is. I'm going to explain that in a second. And then I just add to my number whatever power of 2 that is. So in this case, 0, 1, 1, 1, I would add 4 and 2 and 1 together, and I'd get the number 7. Now, I've got to figure out my power, because in my substring, this is index 0, this is index 1, this is index 2, and this is index 3. But those are opposites of my power, because this is 10 to the third power, this is 10 to the second, sorry, it's 2 to the third power, 2 to the second power, 2 to the first power, and 2 to the 0th power. So my indexes are opposite. So I came up with a formula to figure out the power going backwards. I just took the length of my string, I subtracted 1, and I subtracted I, and that kind of gives me my power. And if I were to run this, I have to send in a string, so I send in a string, and 111. We just saw that that should be 7, so if I click OK, it should return 7. Good. I'm going to do one more. In quotes, 10111. I know these last 3 represent a 7, but this would be, I'm going to add a 16 to it, so that should be 23. And there it is. So that's it for number conversions. Come see me if you need any help.